Hi guys. Okay, so in this video, we're going to look at the learning check problems from chapter 9 on gases from the Open Stax chemistry book. And here we are going to start from the problem 9.11 that relates to the density. All the other previous problems relate to Boyle's law and Charles' law, and you can just do those on your own. But I will look at the more complex ones here in these videos. So the first one, 9.11. What does the 9.11 say? The 9.11 is, what is the density of molecular hydrogen gas at 17 degrees Celsius and a pressure of 760 torr? So let's write down first what is given to us. So you see the density formula that we are going to use is D is equal to MP over RT. M stands for the molar mass of the gas. And in this case, the identity of the gas is important. So we are using hydrogen. So hydrogen is 2 grams per mole. It's a diatomic hydrogen. Okay. Next is the value of P. So the pressure given to us is in torrs. So we need to convert this torr into the atmosphere. So pressure is 760 torr. And we know that 1 atm is equal to 760 torr. So it's okay for us to use this as 1 atm as a conversion. So that's the value of pressure. Now the value of R is a standard, that's the gas constant, 0.08206. And some of the books also say 0.0821. It's the same thing, but liters times atm over moles times K, okay? And the temperature given to us is 17 degrees Celsius. So 17 degrees Celsius plus 273, and that is going to be to convert it to Kelvin. So this comes out to be 290 K, okay? So always keep this in mind that the temperature has to be in Kelvin. The pressure, atm, especially because of the value of R, the gas constant, this is an atm, and the molar mass is right now we are going to use in grams per mole. Okay, so let's now just plug in the numbers. So D is equal to the molar mass is 2 grams per mole times the value of P, which is 1 atm over R, and let's do this here a little bit. Sorry, D is equal to this. So the value of R is 0.08206 liters times atm per mole K times or multiply by 290 K. Okay, that's the temperature. So when you look at this, the units cancel out. So the units are atm and atm cancel out, K and K cancel out, and the moles and mole cancel out. So you're just left with the units of grams and liters. And these are the units for density. And when you do all these calculations, you are going to get the answer. Density is equal to 0.0, this is 0.0847 grams per liter. So that's the answer. Okay, so our next question is 9.12, and here we are dealing with acetylene, which is a fuel used for welding torches. So here it is composed of 92.3% carbon. So we are given 92.3% carbon by mass, and we're given hydrogen 7.7% by mass. We are being asked to find the empirical formula. So find the empirical formula if 1.10 grams of acetylene occupies a volume of 1 liter at 1.15 atmosphere and 59.5 degrees Celsius. What is the molecular formula for acetylene? So here you see that you are given the percent of carbon in mass, and you can easily convert there's 2 grams. So grams of carbon and grams of hydrogen are given. So our strategy first is to find the empirical formula. And that's our step 1. Find the empirical formula, then find the empirical formula mass and keep it on one side. So one part of the problem is solved. The next is, in order to find the molecular formula, you would need to use certain steps and certain formulas. So here, empirical formula times a numerical number gives you the molecular formula. Now, how do we find N? Either you're given the molar mass. Generally, if the molar mass is given, which comes through, experimental or some other methods. So some molar mass would be given to you. You take that molar mass, divide that by the empirical formula mass, and you get this numerical N. And you can simply multiply the empirical formula with that, and you get a molecular formula. But in this case, the real molar mass is not given to us. We are actually given the mass of the acetylene in grams. So here we need to find the moles of the acetylene first so that we can find the molar mass. Okay, so first find the molar mass. So how do we do that? The molar mass is actually the mass that is given to us divided by the number of moles. Now, how do we find the number of moles? The number of moles comes from the use of the ideal gas law. PV is equal to nRT. So this N is the number of moles. So keep that in mind. And this N is just a numerical number. Okay, so number of moles can be found by using the ideal gas law, and we have N is equal to PV over RT. Using this formula, you can get the number of moles. Next is, we know that the molar mass over the empirical formula mass is that N number, that N that you get. Actually, this N you get from here, you are going to apply here, okay? And when you get the molar mass, then you bring that molar mass value here. So this is the way, we are doing that. So first find this, that is the moles. First find the moles, put the moles under the mass that is given, then gives you the molar mass, then you bring the molar mass, and then this number N is this number, the numerical value. Okay, so this is the way we will work with it. So don't get confused with the N's, how to do that. Okay, so let's start solving this problem. So first, let's find the empirical formula. We are given 92.3% carbon. So if the whole sample is 100 grams, then out of that 92.3 grams is the carbon. So that's how this percentage translates into. Same story with the hydrogen. If the whole sample is 100 grams, out of that sample of 100 grams, 7.7 grams is, this is 7.7 grams is 7.7 grams is hydrogen. Using that values, find the moles. So carbon is 12 grams per mole and hydrogen is 1 grams per mole. Okay, so we get the number of moles. So as you can see, when we multiply 12 by 92.3 grams, and when we multiply 7.7 with 1, we get the number of moles of carbon and hydrogen respectively. So carbon comes out to be 7.69, but you can round up right here. So you get like, close numbers. So 7.7 grams of carbon and 7.7 moles of carbon and 7.7 moles of hydrogen. So here's the mole to mole ratio of carbon to hydrogen. And here moles of hydrogen over the moles of hydrogen. So here we have 7.7 moles of carbon over 7.7 moles of hydrogen. Same story, 7.7 moles of hydrogen over 7.7 moles of hydrogen. So here we basically cancel these out and you get 1:1 ratio. So the empirical formula comes out to be carbon and hydrogen, just CH. That is the simplest, whole number ratio is 1:1. So that is the empirical formula. Now, let's calculate the empirical formula mass right here. So this is equal to the carbon is bringing 12 grams coming from carbons plus 1 gram coming from hydrogen. So it's total 13 grams per mole. So the empirical formula mass is equal to 13 grams per mole. Okay, so now let's look at the next step, and that is calculating the molecular formula, and we will do this way. So for the molecular formula, we need to first get the number of moles. So that is the number of moles of acetylene as a gas, and that is equal to PV over RT. So the value of P given to us is 1.15 atm. So put this down here, 1.15 atm times the volume is 1.00 liters over the value of R is 0.08206 liters atmosphere per mole K, okay, times the temperature given to us is in 59.5 degrees Celsius. So convert that into Kelvin. So 59.5 plus 273 gives you 332.5 Kelvin. So bring this here, 332.5 Kelvin. Now here you see the units cancel out. K and K cancel out. ATM and ATM cancel out. Liters and liter cancel out. And only units for moles are left. So the value of N comes out to be 0.0421 moles. Next step is you are going to find the molar mass. So molar mass, which is M, is equal to the mass in grams over the number of moles. Okay. Now mass in grams is given to us is 1. Where did it go? Okay, I think I didn't write it here, but the mass given to us is M is equal to 1.10 grams. So it's there, I saw it now. Okay, so 1.10 grams is the mass over the number of moles is 0.0421 moles. So that would be grams per mole. So when you do the math, you get 26.12 grams per mole. Next thing is the numerical value. So remember that the empirical formula times the number, some number, is equal to the molecular formula. And so in order to find this, what do we do? We get this number, this N. This N is the numerical number. Okay, so in order to do that, you are going to take the molar mass. So in other words, here is the molar mass, which you calculated from the top, over the empirical formula mass. And this is equal to this number, N is equal to this number. Okay, so let me just put this correctly. Okay, so now we have the molar mass coming out to be 26.12, the one that we calculated just now on the top. 26.12 divided by the, and this is grams per mole, divided by the empirical formula mass. And we calculated the empirical formula mass just a while back, which is 13. So here you put the empirical formula mass of 13.0 grams per mole. So these two units cancel out, right? You see that? This unit, grams per mole, cancel out. So that is why this is just some numerical number without any units. Okay, so now N, so now we bring the empirical formula, which is CH, C1H1 basically, times, and when you divide this, this comes out to be 2. So 2 is equal to C2H2. So this is the empirical formula times 2 is equal to molecular formula. So this is the answer. This is the C2H2 is the answer. The empirical formula is CH. Okay. So let's look at the next one.